Cricel villanueva, and for the college algebra project, I solved the problem using the difference quotient.
And I'm Rosybette Aguilar, and I'm going to do the operations of functions.
My name is Carlos, and I'll be solving the polynomial roots and the Aguilar theorem. Is that it?
Hi, my name is Cricel villanueva, and I'm going to be finding the difference quotient of f of x. F of x equals negative 5x cubed plus 2x. In order to find the difference quotient, we are using the formula we're going to use that formula up there. So in order to start this problem, we need to put negative 5, and then for x, we're going to put x plus h. Since x is cubed, we're going to do x plus h plus x plus h times x plus h times x plus h. Okay, so it's easier, and plus the 2x plus h, because there's an x right here. It's easier to multiply 2 instead of 3 altogether and then work down from there. So when you multiply these, you get x squared plus xh plus hx plus h squared. You're basically just distributing the x and then distributing from there. When you do that, you can combine the like terms and xh becomes 2xh. And then you just bring down the x plus h, and then you bring down the 2 and the x plus h. From there, you want to multiply this big long problem by this. So basically what you did up here, but just it's longer. So if you multiply x squared times x, you're going to get x cubed. And then from there you go to x squared plus h. And that's going to get, you're going to get x squared h. And then you just work from there. Okay, so after you do that, you're also going to bring this back down. Now you're going to distribute the 5 into your big problem right here. What's this problem? Distribute the 5. When you distribute the 5, you get negative 5x cubed minus 5x squared h minus 10x squared h minus 10x squared h minus 5h squared x minus 5h cubed plus 2x plus 2h, because you distributed the 2 also. When you do that, since this, what we found right here, is the fx plus h, now all we have to do in order to finish the problem is we're going to plug that in. So f of x is what we started from in the beginning, and f of x is going to be negative 5x cubed plus 2x. So you're going to subtract that from the problem that we did. There's a lot of work to it, but it's actually very easy and simple. It's a lot of distributing and combining like terms. So what we're doing now is we're going to distribute the negative, and that's going to become a positive 5x cubed, and then we're distributing the negative, and it's going to be a negative squared x. So now what we're doing is we're going to cancel out the like terms. So negative 5x cubed is going to cancel out with positive 5x cubed. It's positive because we distribute the negatives. And 2x is going to cancel out with negative 2x. Now what we're going to do is we're just going to bring the rest of the problem down. So all this right here is going to come down. And now we're going to, since that big problem, everything that we brought down is what is up here, is what's there. We're just going to put h under, and we're going to cancel out the h's. So when we cancel out the h's, we get negative 5x squared minus 10x squared minus 10xh minus 5hx minus 5h squared plus 2. So now we're just going to combine the like terms. And after you combine like terms, your final product should be negative 15x squared minus 15xh minus 5h squared plus 2. Finding the difference quotient may look a little bit hard, but it's actually really easy. If you think about it, it's really just distributing and combining like terms. It's easy to work slowly with it instead of trying to do it all together. But yeah,
Okay, so what we're going to do is f of g of x, and you're going to plug in g of x inside of f of x. So it's going to be x squared plus 3x plus 4 squared minus 5 parentheses x squared plus 3x plus 4. And then from there, you're going to do the FOIL method for x squared plus 3x plus 4 times x squared plus 3x plus 4. From there, you're going to do the arithmetic, and you're going to get x to the 4th plus 3x cubed plus 4x squared plus 3x cubed plus 9x squared plus 12x plus 4x squared plus 12x plus 16. And from there, you're going to end up combining your like terms. So it's going to be 4x to the 4th plus 6x cubed plus 17x squared plus 24x plus 16. And then you're going to bring down the rest of the formula, and it's going to be, equation, and it's going to be negative 5x squared minus 15x minus 20. What I did is I distributed the negative 5 in what's inside the parentheses, and then from there I combined like terms, so it's going to be 4x to the 4th plus 16x cubed plus 12x squared plus 9x minus 4. And that's your answer. And then now we're going to move to part B, which is g of f of x. So it's going to be, you're going to plug in f of x inside of g. So it's going to be x squared minus 5x squared plus 3x squared minus 5x plus 4. And like I said before, you're going to end up doing the FOIL method. So it's going to be x squared minus 5x times x squared minus 5x. And like the previous problem, you're going to end up doing the arithmetic. So it's going to be x to the 4th minus 5x squared minus 5x squared minus 25x plus 25. So it's going to be, you combine like terms, and it's going to be 4x to the 4th minus 10x cubed plus 25x squared. And then you would take that back to your equation and you plug it in, and it's going to be x to the 4th minus 10x cubed plus 25x squared. You distribute the 3 in what's inside the parentheses, and you're going to get 3x squared minus 15x plus 4. And like before, you combine like terms. So you're going to get x to the 4th minus 10x cubed plus 28x squared minus 15x plus 4. And that's your answer. And now, moving to part C. In this part, you're going to do f of x. So you're going to plug in f of x inside f of x. So it's going to be x squared minus 5x squared minus 5 parentheses x squared minus 5x. And like the problem before, you already did the arithmetic for that FOIL problem, so you can just follow along on this one. So it's going to be x squared minus 5x times x squared minus 5x. So you're not going to end up getting x to the 4th minus 5x cubed minus 5x cubed plus 25x squared. And if you combine like terms, it's going to be x to the 4th minus 10x cubed plus 25x. And like the previous problem, you take that back to your equation and you plug it in. So it's going to be x to the 4th minus 10x cubed plus 25x squared. And you distribute the negative 5 to what's inside the parentheses. So you're going to end up getting negative 5x squared plus 25x. and then you combine like terms, and you're going to get x to the 4th minus 10x cubed plus 20x squared plus 25x. And that's going to be your answer. And from there, we're going to move to part D, which is g of x. So what you're going to do, like that previous problem, you're going to plug in g of x inside of g. So you're going to get x squared plus 3x plus 4 squared plus 3 parentheses x squared plus 3x plus 4 close parentheses plus 4. As in part A, you already did the arithmetic for the FOIL method for that problem. Well, for that part. So you're just going to copy down what you did on part A. So it's going to be x squared plus 3x plus 4 times x squared plus 3x plus 4. So you're going to end up getting x to the 4th plus 3x cubed plus 4x squared plus 3x cubed plus 9x squared plus 12x plus 4x squared plus 12x plus 16. And you take that back to the original equation and you plug that in to where it was before. So you're going to get, you also combine like terms. So you're going to end up getting x to the 4th plus 6x cubed plus 17x plus 17x squared plus 24x plus 16, and then from there you distribute the 3 inside what's inside the parentheses, so you're going to get 3x squared plus 9x plus 12 plus 4. And then from there, you combine your like terms, and you end up getting 4x to the 4th, x to the 4th, sorry about that, plus 6x cubed plus 12x squared plus, sorry about all of that. It's going to be x to the 4th plus 6x cubed plus 20x squared plus 33x plus 32. And that's
I will
going
be
to
solving for the rational series of this polynomial using synthetic division according to the factors of 9 and 2. For number 1, I will use synthetic division for this. 2, 5, 3. Now I will use synthetic division. Bring down the 2, and so on and so on. So with this, I can determine that this is not 0. And for -1, I will do the same. I bring them to 2. Okay. And the remainder is -24. And I can determine with that this will not give me a 0. I'm a step above, but please ignore. So again, it's half, 1 over 2. And same thing, synthetic division. Over 2, 5. Over 2. Again, the same, synthetic division over here. So it's 9. And this will make a 0. Let's see, yes. This is our first 0. Okay. And for negative half, negative 1 over 2. Same thing, synthetic division. 2, 5, 3, 15, and negative 9. For this side, again, negative 2. Multiply all that stuff. Okay, just gonna see this. This is not, nope, not a 0. So, keep going. Starting at 3, the numbers were getting a little large, so did them off camera, but same deal. It's just synthetic division. Both of these, 3 and negative 3, gave me things that were not 0, so they're both not zeros. Both 3 over 2 and negative 3 over 2. The remainders are both higher than 0, so they will not be zeros, either of them. I went ahead and finished 9, negative 9, 9 over 2, and negative 9 over 2, just because their numbers were starting to get ridiculously large. But yeah, any of these just gave me a 0. All of the remainders are very much higher than 0. So that leaves me with the only rational 0 as 1 over 2.